In today's class, we would be talking about what exactly AI is, what exactly deep learning is, what exactly machine learning is, how and where this Gen AI concept comes from. And then I would also be talking about uh, what would be the course plan of action. And then I would be asking you to set up an work environment or the environment that is needed for this entire course as well. So, with that in short, let me start by showing this diagram. So, this diagram depicts that there are few things like what exactly artificial intelligence is, what exactly machine learning is, what exactly deep learning, and then now people are talking about Gen AI, and then our course is also on Gen AI, and then there is one more thing called natural language processing. So we will see what exactly these terms are. Uh, yeah, and then why this Gen AI got so much popular, and then why now companies are planning to move towards this Gen AI and all. We'll see all these aspects in detail. Let's start. I think in yesterday's class, we have seen all these companies and then what companies are manufacturing LLMs. So you need to have a clear understanding because I would be using these terms quite regularly. So OpenAI is one company, as I mentioned. By now, you know OpenAI, and then you have used ChatGPT as well. So ChatGPT is a product. Under that product, there are models. So GPT-4o is one model, and then there is something called O3 model, which is called reasoning model. Yeah, I mean, these large language models are broadly classified into two things. I can say one is called base model, second one is called reasoning model. So what these base models try to do is that they try to do everything for us. So if you can ask, 4o is I can say it is a base model. So if you can ask to create an image, base model can do that. If you can ask to ask any question like write me a code for this or assess, I mean, if you're given a requirement, ask to code that, it will do that. Or if you want to create an architecture diagram, it can do that. Or if you want to estimate the cost, it will do that. Everything. So base models are, I can say, they are good at everything, but not it cannot do reasoning stuff. So if there is a problem statement, what generally human does is that he try to first think or he try to reason on what has to be done, right? So as I said, base models, every company, let it be OpenAI, Meta, Google, Anthropic, DeepSeek. So it has been classified into two things. One is base models, second one is reasoning models. Reasoning models are good at coding. Reasoning models are good at solving the problems very efficiently. So yeah, please try to look on to the reasoning models as well. There is O3 mini, O3 mini high. So all these are reasoning models. GPT-4o, GPT 4.5. So all these are called as base models. Okay. So based on your task, you'll choose what model to use, whether it can be a base model or you can use normal. It cannot be, let's say, if you're working on answering the questions, you don't need a reasoning. So you can directly use 4 or 3.5 turbo, or you can use any other base model. Let's say if you are building a product where that products uh, need to, let's say if you are creating a Devon AI software like that, where this AI has to create a product, create an AI engineer. Then you have to have first you have to have reasoning on. Let's say if you're given a requirement, you have to draft the steps on what you need to do, and then after reasoning, you need to execute each and every task. So as I said, this classification helps us furthermore to choose what large language model to choose as well. So and there is one more company, or I can say this is a startup which is called Perplexity. .ai. I think you have used this perplexity.ai as well, where this is just a wrapper. Murli, can you be on mute? So yeah, Perplexity.ai is a company. It is just a wrapper where if you ask any question, it try to search from Google and then it will give us the answers. Okay. So yeah, that is a wrapper thing, and then there is one more thing called Grok. Yeah, Grok.
చూసి చెప్పినా నాకు కావాలని.
Uh, yeah. So there is, as I said, there is one more wrapper thing which is called Grok. Yeah, Grok is also a wrapper where, let's say, if you want to utilize a large language model, let's say if you want to consume the large open source large language model, you can consume it from here. Okay. Yeah. Anyhow, we will be talking about this in detail, but please understand these companies and then what their large language models are, because we will try to use these large language models into our applications. Now let's talk about the terms that I mentioned previously. Let's talk about what exactly artificial intelligence is, what exactly machine learning is, what exactly deep learning is in detail. So the term machine learning is not new, guys. It was way back in 20th century, I can say, specifically in 1960 or 1959. There was an author called Samuel. He defined machine learning as computer can learn without being explicitly programmed. This was the rough definition, I can say, that author Samuel has given us. So what's his main intention is, let's say if you are given an image, you need to identify whether an image is cat or dog, or you need to identify whether an image is Donald Trump or Narendra Modi. So you don't need to write an explicit program saying that from this pixel to pixel, and every image consists of in pixels, right? So and the image is just a combination of three matrices, RGB. So if you combine RGB matrices, you'll get a colored image. So yeah, if you are given an image, you don't need to go for a pixel, and then you should not decide. You should not write an explicit code to decide whether a given image is Donald Trump image or Narendra Modi's image. Without explicitly programmed, you need to decide whether an image is image is Donald Trump image or it is somehow Narendra Modi's image. That is what the definition that Arthur Samuel has given in 1960s. But in late 1990s, Tom Mitchell has given a statement or a definition saying that a computer can learn from experience E with respect to some task T if the performance P while performing task T improves over E. So this definition is definitely confusing. Let me break these things for you guys. Let's assume that you are playing a game, chess game. Let's assume that you are playing chess game. What is your task? Obviously, let's say if computer is playing against you, what is the task of the computer? Here, the task of the computer is to win against the human, right? That is the task that we are defining for the computer or for the chess game, where it is playing against. So the task is to win as many games as it can whenever it is playing against the opponent. What is the experience? Experience is the number of games that it is playing. And what is the performance? If you perform a task, then definitely we will assess its performance, right? Let's say if you play against the computer, then the performance would be the number of games that it is winning. So these three terms are important. So task would be playing the checkers game or playing the chess game. Experience would be number of games it is playing against its opponents. So if experience increases, obviously my performance will go high, right? Yeah, and then performance is the accuracy or the number of games that it is winning or number of games it is losing against the opponent. So what he take these three terms and then he defined machine learning as if the performance T while performing a task T improves over E. So let's say if I am performing a task T, my performance will always goes up if I'm having greater experience. If experience increases, what he's trying to say is that performance will also be increased. Yeah, that is what the simple definition that Tom Mitchell has given in 1970s. But you don't need to know all these terms. The simple definition of machine learning is what we are trying to achieve in machine learning is that. So if you can see this diagram depicts or diagram states that this is a bigger branch. Under this bigger branch, there is something called machine learning. So you can say artificial intelligence is a subset of machine learning is a subset of artificial intelligence, or it is a branch of artificial intelligence where computer learn to make decisions or predictions without explicitly being programmed. Or what we can simply say is that we have data. What we are trying to do is that with this data, we are trying to find the patterns, okay, and then we are trying to predict the future. That is what exactly machine learning, what we are doing in machine learning. So let's say if I have a data set which is called a spam or ham data set. So let's say if I get a new mail, what I need to do is that I need to determine whether an email is spam or not. That is my task. How am I doing the task is that with the help of experience E. What is the experience E here? Experience E is the data source or the data that I'm having. What is data here? The data is a bunch of emails, whether it is stating whether it is an spam email or ham email. Okay, so I'm having the data, and then I'm having my task. Now, what I need to do is that uh, I need to take the data and I need to find somehow patterns. So how am I finding the patterns is modeling, I can say. We have so many models that helps to figure out or that helps to find out the patterns. So yeah, so what I'm trying to do is that I'm having data, and then with this data, I'm trying to find the patterns or commonality in that data. After finding these patterns, for let's say if I'm getting a new mail, what I'm trying to do is that I'm trying whatever the patterns that I'm getting from the data, I'm trying to apply this for new data, and then I'm predicting for that new data whether it is spam or spam. So simply machine learning, if we have data, we will find the patterns and then we will predict for the future actually. That is what exactly on a high level machine learning is all about. So yeah, this machine learning is pretty old. I would be taking one class about what exactly the various models under machine learning. But yeah, on a high level, machine learning has been classified into three types. For this large language models itself, we need to know these two techniques, which are very important. Mm, because machine learning is built, I mean, the large language models are built on top of this unsupervised technique and then reinforcement learning technique, actually. So let's talk about these three terms, or let's talk about different types of machine learnings. So, what exactly supervised machine learning is? What I can say is that let's assume that so machine learning always works on data. So we have data, and then I need to find the patterns. How I find the patterns is this classification, I can say. So first one is supervised machine learning. So where in supervised machine learning, what I would be having is that I would be having a data set where you can assume that spam or ham, let's assume that that is my data set. So in that data set, what I'm trying to do is that I will be having data set with input data, and then I would be also having labels. So what do I mean by input data, and then what do I mean by labels is that, uh, let me try to share my screen, black screen, guys. So are you guys seeing my black screen? Yes or
Yes.
no, man?
Yes.
Okay. So yeah. So let's assume that I do have a data set. So in this data set, I would be having X and Y. So X is nothing but an input, and Y is nothing but an output. So in input would be, let's say, a mail saying that congratulations, you won a lottery for 1 million. Okay, $1 million. So this is an email, and then what should be output, whether it is spam or ham? It would be definitely a spam mail. So and then I would be having certain records like this. So the collection of these records is called a data set or a data set. So what I would be doing is that if I have a data set with the input and then if there is some classification like this, then I would be applying some supervised techniques. So let's say what we can classify is that if I have a data set with input and then the classified label to it, then I would say this kind of machine learning technique as supervised machine learning technique. Okay, and then let's assume that I am working on a problem where I have, uh, let's assume that I'm working for Amazon. Okay, I have customer details or customer information. I just have customer information on what they are buying. Okay, so there are few customers where they are always buying new gadgets. There are few customers who are interested in buying home appliances, and then there are few customers where they are more interested in buying clothes and all. Okay, what this Amazon company or the e-commerce guys does is that they try to segregate you or they try to cluster you into a group where let's say if I got a new product, a new gadget, then what I will try to do is that I will try to recommend or I will try to send some notification to only this kind of customers. This segmentation can be, or this grouping can be done based on location, or it can be done based on similarity on what they're doing. So here I'm just having customer information. I just have input, but I don't have any output here. I'm not having Y here. So, but for previous thing, for spam or ham, or for predicting whether patient will be having diabetics or not, or whether a patient will be readmitted in next 30 days or not, or whether a transaction is fraudulent transaction or not. Let's say if this kind of data where we would be having a transaction, and then I'll also be having whether a transaction is fraudulent transaction or not. So I'm having X and Y, I'm having input and output. So if data is looking like this, we would be applying some sort of modeling techniques. These modeling techniques are called supervised modeling techniques. If data is, I'm just having input data, and then let's say if my data doesn't have any output, then I would be applying something called unsupervised techniques where I would be applying something called clustering, or I would be applying something called anomaly detection. Yeah, there are some unsupervised techniques as well. So the main difference is that in the data set, if I have input and output, I'll apply supervised machine learning techniques. If I only have input but not output, then I will apply unsupervised machine learning techniques. Then what exactly reinforcement learning is all about? So in this reinforcement learning, guys, which is called RL, I mean, I think by now you understand. You got DeepSeek. ChatGPT is one company, and DeepSeek is also a company. Not ChatGPT exactly. OpenAI and DeepSeek is a company. As I said, the training whenever they are building this ChatGPT or whenever they are trying this large language model, which is called GPT-4o, they got up to 10 billion to 50 billion to train a model. The cost for training that model is 10 billion, and then the training for DeepSeek is just 5 million. It is billion. There is huge disparity in price of training a large language model. So why that happened is that they come up with something called reinforcement learning training, which has worked very well. This is the new concept that got introduced in this DeepSeek as well. Anyhow, I'm gonna talk about this DeepSeek in one class. I will be taking a dedicated class on how these guys come up with that model. So I would be using that in other class, but yeah, the reinforcement learning is such an important concept as well. Previously, there was not much research, active research, but now after this, people are working on reinforcement learning as well. Yeah, what exactly reinforcement learning is? Reinforcement learning is all about mm, maximizing the rewards. So what do I mean by that? So let's assume that I'm designing an I'm designing a car uh, which has to drive automatically. Okay, a self-driving car. So to design this under the hood, people have invented this reinforcement learning techniques, I can say, where if I have a car, uh, if this car has to move from point A to point B, uh, I will be training my car with so many set of samples, okay, on what to move, how to move, what speed to move, what parameters that it has to consider whenever it is moving from point A to point B. So after training with so many examples, now what I'll do is that I'll add a stone. Uh, I'll add a stone whenever a car is moving from point A to point B. Now, first time, what this car will do is that even though it is having a hurdle, it will not stop and then it will directly go and collide with that body actually. Okay. So, because it is not trained on the particle or it is not trained on that stone, what this car will do is that it will go and collide with that object, whatever the object that we have to placing. Now, what we'll do is that now we will assign some sort of negative reward if it performs a mistake. Okay. Uh, Now at the end goal is that if the car is moving with good pace, let's say if there is any uh, distraction or if there is any object as such, if car takes a right direction and then if it moves from point A to point B, then we'll assign a positive reward. Okay, this reward system is a key integral part of this reinforcement learning. If a mission or if an agent performs if agent performs a task and then if task is if it is performing the task successfully, then we will assign the positive reward. If it is performing negatively, then we'll assign a negative reward. So ultimately, the end goal of this agent or the car is to get the maximum reward, right? Obviously, it has to perform the task successfully. So this reinforcement learning is all about that. Uh, the end goal of this reinforcement learning is to create a system where it has to perform and then it has to give us the good results. Yeah, if it comes to chatbot, how whenever they are training with this chatbot kind of things, our end goal of our chat is that customer has to satisfy it. I mean, let's say if he's asking any question to our large language model or GPT like models, what it has to do is that it has to give us the right responses in right time, right? So let's say if a customer is asking question like, uh, what would be the impact of tariffs on economy or on the global stand, then LLM or has to give us the response in such a way that the customer who is looking for the answer has to be accurate. If the answer is not so accurate, if he feels that, he will be definitely, you might be using ChatGPT as well. There is feedback system where after getting a response, it is asking for thumbs up or thumbs down. Based on the thumbs up or thumbs down, we are assigning, and in the back end, we are assigning a positive reward or negative reward. So if a system is getting negative reward, if a chatbot is if LLM is generating negative responses, then we as customer is giving the negative response, our LLM would retrain in such a way that our ultimate end goal is to get the positive or maximum reward. Yeah, these are the, I can say, broad classification of machine learning and what exactly machine learning is. I'll take a stop here, and then if you have any questions till now, you can just ask, or else what I can do is that I would go ahead. Yeah, Babu, go ahead. I think you raised your
Sorry,
hand.
yes, I'm not expert, but I will try to ask question. See,
Okay.
in the first supervised learning, you know input is X, you get output Y. Then based on that, you make prediction. In the future, data comes based on that
Mm-hmm.
prediction. Say that fraud or good or bad we can do. That is a statistics. Okay. Yeah.
Mm-hmm.
Where unsupervised learning, there is no output. How do I say that it is a good? Is an apple? Because I don't know what is. Just I'm saying that I throw some fruit. I would know that there is an apple or orange. Am I right? That is
Mm-hmm.
should be recognizable. If I
Mm-hmm.
don't know any behavior, I don't
Mm-hmm.
have any pattern. If I
Mm-hmm.
don't know what is the output, how
Mm-hmm.
do I? That maybe I'm not sure how the system will know that.
Okay. Okay. So what we are trying to do, I mean, that is the question, or do you have anything else?
That is why just if unsupervised learning means system does not have any data. Am I right? What is the
Yes.
output pattern?
Yeah,
But
we
still
will be
give
having
some
data,
output.
but we will not be having an output associated with that data.
Yep.
Yeah.
How it will come to know that it is
Okay,
good or
got it.
bad if
Got
you don't put
yeah.
any input?
Yeah, got it. Got your question. So what we're trying to do in unsupervised technique is that we are not deep diving into the patterns or anything like that here. So what we're trying to do is that we are trying to find the proximity. Let's say if there are uh, if there are apples, and then if there are oranges which are mixed into a system, then what we are trying to do is that we are trying to find the distance between apple to apple, and then if the distance is small, what I will do is that I'll try to group them. So you might be seeing in Google Photos as well, or in Apple Photos, what it try to do is that it try to segregate your photos into one, or your wife photos into one, or your children photos into one folder, right? If you see favorites. So how it is doing is that it finds the distance between you and the other photo of yours. If the distance is small, if the proximity between these two images are small, then I'll try to group them. So here only grouping takes place or clustering takes place with distance or with proximity behavior. So I'm not trying to find any patterns
Perfect
as such,
example. You
or
gave in app most of the times I don't know that pictures are grouping and showing to us. Yep, you're right. Yep.
yeah. Yeah, thanks for that question.
Yeah, no, I
Any
didn't
other
know that,
question?
but you answered. I was thinking always amazing how this old 10 years back pictures comes every day. Group
Yeah,
them. Yep.
yeah, got it.
I Shekhar, I got one question in supervised learning.
Okay,
Uh,
go ahead.
To begin with, there are some initial patterns were there to decide it's a bad apple or like a good apple.
Okay.
So there are existing patterns already there to
Yes.
decide to determine.
Yes,
Okay.
there are existing mathematical foundational models, I can say, where these are Kickstarters. We will use that mathematical formulation, and then we will decide on whether it is good apple or whether it is fraudulent. It will look into all the fraudulent transactions, and then it will come up with how exactly fraudulent transaction looks like, or how exactly the spam mail looks like. So yeah, as I said, there are so many models or modeling techniques that helps us to find out the patterns that are there in the data. Yeah, I'll talk about that in one class specifically about the supervised and unsupervised techniques. But yeah, to kickstart, yes, there are few modeling techniques or mathematical techniques that helps us to find the patterns inside the data. Is that clear, or
Yeah. Okay.
okay,
Yeah.
got it.
Thanks.
Okay. Yeah.
So just one quick question,
Mhm.
Shekhar.
Go ahead.
So
Go
you're
ahead.
saying that reinforced learning is who's this guy DeepSeek, right? DeepSeek focused, or he built this reinforced learning, right?
Mm-hmm. Mm-hmm.
Which is which is not trained. If I think you must have watched a video where in Nigeria, they hire people to train the images, right? They just pay $2 per day, and then they capture the image and train. This is a stone. This is a beach. This is a seashell, right? That's how they train. And the part of the Google classification of your photos is also because of those training, right? Which is actually
Annotations, right? This is called as annotation. Yeah.
So that's also called supervised, right? Can we say that?
I mean, but sometimes the annotations is a kickstart. But let's say if I'm taking a new picture, I'm not somehow annotating it to be my or my wife's image. Internally, it is classifying which folder to go. So it is, I can say, mixed because under the hood, whenever they are training as a base model, they would try to annotate a few pictures saying that this is a type of an image called beach, or this is Niagara Falls. So they'll try to annotate for base model thing, but in real world, we will not be getting an annotated images. So it is some, you can say, whenever we are building this stuff, we some kind of using supervised techniques, but it is also a combination of supervised plus unsupervised. This is also called a semi-supervised machine learning. There is fourth type of classification that I haven't introduced you, which is called semi-supervised technique, where it is combination of both supervised and unsupervised. As in real world, we will in some situations, let's say if you have a clinic, or if you are having a VA, or if you are having a clinic, or if you are having a hospital, we will be having data itself. Sometimes we will not be having an output of whether a patient is a diabetes patient or not. For some records, we would be having that. Let's say if there is any guy, if there is an annotator who always annotates, look into data and then annotates this stuff, then only we will be having X and Y. In most of the scenarios, we will be only having X. In my example of a VA clinic, or in any other case, or let's say if you are working for an insurance company, or if you are working for any banking sector, in most of the cases, we will be having the input, but not the output associated or label associated with that data, actually. So in that cases, people generally try to use something called semi-supervised learning, where it is combination, where we will be having some data with labels and some data without labels. I think I went off topic, but is that answering your question?
Yeah, sort of. I don't want to hold up you here, but kind of a lot of people.
Okay, yeah, a lot of info to cover. But yeah, let's say if you have any other further classification, we'll cover that at the end of the class.
You can think through this. Yeah, you can think through this and probably touch upon this. Just one quick question was: so even the supervised learning and supervised reinforced learning, right? Eat this. You're saying eat this thing because it will keep you alive, right? Now, like I said, if I ask even ChatGPT, the Grok or anything, DeepSeek, or what's Gemini AI, right? Copilot, they all tell you if I ask, can you give me a statement like what Donald Trump would describe, an apple, or how Narendra Modi would describe an apple. So it will actually tell you with with annotation and everything. So all this AIs will do, right? Any AI platforms will do. Now, is it not also a reinforced learning, because there's no labeling, there's no sample annotating, nothing, right?
Sure.
They just need a mass data.
Got it. So whenever all these large language models are trained on, they use this concept called unsupervised techniques. All these large language models are using something called unsupervised techniques, where how exactly the LLM works is that, let's say there is a statement called eat this thing because it will keep you alive. Let's say this is a statement. What I will try to do is that I will just pass eat to my LLM, and then I want LLM to predict this. Okay. In the next go, I'll pass my LLM with eat and this. Now I want LLM to predict thing. Obviously, if you pass it and this, LLM will not predict thing actually. It will predict something. Now what I want LLM is that LLM want to I want to do backtracking, and then I want LLM to predict the thing actually. So this is called under the hood, whenever they're training, they haven't used, OpenAI initially haven't used this reinforcement learning, but they have used unsupervised technique. If you want, whenever I'm talking about LLM or transformer, I'll talk about how they have trained this model. But let's keep our discussion here, saying that there are three types of classes, three types of categories, which is supervised, unsupervised, or reinforcement learning. I'll talk about that in detail, Kevin, whenever I'm talking about how to pre-train a large language model or how to fine-tune a large language model. Okay, so okay, so and let's talk about deep learning now. What exactly deep learning is? So as you all know, and then I'm also talking about this deep learning in demo classes. If you have attended my demo classes, you might be knowing how exactly information is stored. So, in our human brain, we are storing information inside something called neuron. Neuron is capable of storing the information, not our brain. And I have given some examples like paralysis and all this stuff. I don't want to repeat myself. This deep learning is a concept that was inspired by human brain. There are three scientists in AI world. They are called as godfathers of deep learning. One is Ann Lukun. He is a chief scientist in Meta right now. He's very active in social media platforms like X and then LinkedIn. You can follow him. And then there is one more of AI. He is called Geoffrey Hinton. Geoffrey Hinton is associated with Google till last year, but right now he is not with Google anymore. And then he is working on ethical AI. Actually, he is showing the world that what could be the impact of this Gen AI and then the dangers of Gen AI. We don't want this LLM to be released like this, and then because he is looking LLMs in another direction. Now he is in different mission, and then he is also a Nobel Prize winner last year. And then there is one more guy. To keep things very short, these three guys believed in this neural system or neural network because from 1980s to 2000s, late 2000s, people, this is called sleeping era of AI, where people has thrown this neural network concept away, and then there is not much research that's going on in this deep learning. But these three guys believed in this neural network concept, and that is the reason why they got Turing Award as well. Turing Award is the highest civilian award that is given to computer scientists. And then they were named as godfathers. And then now in physics and then in chemistry, somehow people are getting Nobel Prizes as well. Yeah. So what exactly Neuron does is that, I'll send you a video after this class on how Neuron is stimulating this stuff. Let's say if you want to recollect something or how neuron processing is done, how neurons are connected and all this stuff, what energy is released. I'll send you a video that is a bit inspiring thing. If you are interested into neuroscience and all, please watch that video because I'm not a neuroscientist expert or something like that. I'm just a Gen AI resource. This deep learning is also under the hood of, under the umbrella of AI, I can say. It is subset of machine learning, where the most of the concepts are inspired by how human brain works. Let's assume that if you are sitting, if you touch a hard body, what happens? If you touch a hard body, what happens? What happens is that whatever the neurons that are there in your hand will send a signal. There are trillions and trillions of neurons that are there in human body. If you touch a hard body, what happens is that the neurons that are there near your hand will be activated, and then they send this information to your brain, and brain processes the request of whatever the neurons are sending, saying that he touches the hot body, and brain processes that request, and then brain sends the information to the hand saying that please remove your hand. So this happens in fraction of seconds, I can say. Within a fraction of seconds. So this is the concept that was inspired, and then everything is put into this neural system. Everything is, if you're seeing here, everything is a neuron. So what we are trying to do is that we are trying somehow doing some mathematical operation, and then can you be unmute, guys? Someone unmute themselves. Yeah. So what we're trying to do is that we are trying to activate this stuff, and then we are somehow inspiring this stuff from our brain, and then they put into this thing. And then now if you pass an image to this neural network, what this neural network is trying to do is that this neural network is trying to predict whether an image is Donald Trump's image or Apple image or cat image and all this stuff. So yeah, and in this, machine learning always talks about, I can say, numerical data. It's mostly on numerical data, and deep learning is it talks about image data. Actually, let's say if you have image, we can apply CNN techniques, and all this stuff actually. So in rough senses, what I can say is that if you have a fraudulent transactions, or if you have house pricing prediction, or if you're working for a real estate company, what our goal is to identify the price within that area actually. So if there are applications like that, then I would choose machine learning. If there are image information, then I would choose deep learning kind of models. And there is one more thing. This is the deep thing, what's inside each neuron. I would talk about this as in first class. I don't want you to feel what exactly weight, how exactly weight happens, how exactly activation does, what exactly is activation is all about. But yeah, I'll talk about this in our further classes on what exactly this network is. This is a bit complex network, but yeah, if you zoom into one thing, it looks like this actually. And next is NLP, where in NLP, I would be talking about text. Let's say if we have a text, it's about finding some sort of how exactly a word is related to other. Okay, next we will be talking about transformer architecture. In transformer architecture as well, we will be talking about self-attention. Okay, what exactly self-attention, or let's say if we have a statement, let's say I have a statement like, I am 23 years old and I need to work, I am Nagashekhar and I am a Gen AI trainer. So let's say there are two statements like this, or let's take other statement like, I like Italian food and this restaurant is bad at something. So let's say if there are two statements like this, and if I want to find some relationship between these words, or if I want to find some attention or self-attention between these two words, the self-attention is how one word is correlated to other. Then I need to use this NLP concept. There are a bunch of NLP concepts. Let's say if there is a bunch of text, we need to pre-process that text, saying that if there is any full stop, then meaning changes, right? So we need to identify what is punctuations that are there. There are techniques like tokenization, lemmatization, stop words, all this stuff. Actually, this is an era of text where I would be reading into text, filtering the text. Let's say if there is any bad text, I would remove that. I will be doing hell lot of thing under this NLP. So now machine learning, as I said, I would be working on numerical data. Deep learning, I would be working on modeling the images. And in NLP, I would be talking about text senses. There are a bunch of techniques that I can talk or we can talk, but the major area or under this NLP, what we would be trying to do is that we would be trying to generate something. Okay. So then what exactly Gen AI is? So Shekhar, I'm good with all this stuff you are saying. I understand what exactly machine learning is, what exactly deep learning is, what exactly NLP is. What is the need of this Gen AI? Why this Gen AI got into boom is that till now, what these AI systems are doing is that they are individualized for specific tasks. Let's say if there is an AI system, what this AI system is doing is that AI system is just identifying whether an email is spam or not. Or if let's take another an AI system, what this other AI system is doing is that that other AI system is somehow is auto-filling this stuff, or other AI system is just predicting whether a transaction is fraudulent transaction or not. So, and then if you think about this machine learning or deep learning models, they are not somehow generating the new thing. They are somehow finding the patterns that are existing in the data, and then it is trying to predict something, but it is not new. So this is generative AI. Let's say if you take an image, how our human brain is processing that it as an image or not. Let's assume uh, you have a three-year-old kid where he don't know what exactly an cat image is, dog image. If you show him and ask him whether it is cat or dog, he will not be able to differentiate that because his brain is not trained on that, right? So if you train him saying that, hey, dog has four legs, and then it will bark, and then you can show some similarities or differences. Let's say if you show a cat, and then you can ask him that, hey child, this is cat, and then the cat, and the difference between cat and dog is that cat has four whiskers, whereas dog doesn't have that whiskers. Whisker is you can say that is the main difference between cat and dog, right? So yeah, that the nuances that we are teaching is very important. Deep learning is all about initially taking the image, identifying whether it is cat or dog. That is what one aspect of our human brain. The other aspect of our human brain, what it also does is that you can assume right now, if you can sit in a room and then you can assume that uh, you are in Goa, and then you are doing skydiving. So you can assume that this is what the generation is all about. Now, all this traditional AI, it is just like classification, all this stuff. Whereas this Gen AI, what I can assume is that it is just like our second level of thinking, where uh, if you are asked to, if you are given a poem and then if you are asked to substitute few words, you can do that, right? So it's all about generating the text. AI, now what generative AI is doing is that it is generating the text, it is generating the image, it is generating the video, and then it is also generating some music. Have you heard about this music apps? I mean, right now there is some copyright issues as well. There are some companies companies are sued by famous music actors as well, right? So yeah, it is generating music. It is let's say if you are speaking something, it is trying to convert into text and all this stuff. Yeah. So now we moved into different era where everything is generated instead of an AI system which is doing a single task or something like that. So yeah, I just want to show you as we are having some time, I just want to introduce you to this Grok Cloud platform, or it can be ChatGPT. I think by now you have used the ChatGPT. So I don't want you to show ChatGPT. Yeah, but you can go for ChatGPT and then you can look into ChatGPT playground as well. So this is an user interface where you would be asked. There is where you would be asking questions like, "Hey, I want to know what exactly the temperature is, or what exactly machine learning is." So here you'll ask question like, "What is machine learning?" Okay, that is the question. This is called prompt. And then you would be having here you would be having something called a temperature parameter. So what exactly temperature parameter is? Let's say you want your answer to be factual. Let's say if you're working for a company where you want answer to be accurately, you want that answer to be getting from the document itself, or there is some factual information like uh, when was this war happened? This war happened at that moment of time. So if you ask when was Pahalgam attack happened, it is 2025. No matter who asked that question, you want that answer to be fixed, right? You want that answer to be factual. Who is 46th president of United States? It is Joe Biden. Who is 47th president and 45th president? It is Trump. So all these are factual questions. If you want answers to be grounded, if you want answers to be factual, you'll put temperature to be to 0. And then if you want some answers to be creative, let's say if I'm writing a poem, or if I want to write an essay, which is to be published in an article, then I want my answers to be more creative. So in that case, I would choose my temperature to be 1. So the temperature is a parameter which is set to be 0 and 1 in all the cases, where 0, if you want the answers to be grounded, I would choose 0. Or if my answers to be, it has to be more creative and more creative, then I would choose a temperature parameter. There is something called top P parameter, which is these parameters are very important for interview as well. They'll definitely ask you, let's say, hallucination is a problem that we are getting with these LLMs. Hallucination is, let's say, if you want an answer to be something, and if LLM is generating the answer, which is not the user is expecting, or whatever the intentions are, this problem is called hallucination. If LLM is generating something and then if that is not your expected output, then that is called hallucination. How do you overcome that hallucination? Is that one answer is you can set temperature parameter to be 0, or in 2 or 3 interviews, he asked me what is temperature as well. So yeah, so you need to know about this temperature, and then there is something called top P, where I'll talk about the top P parameter in prompt engineering. And then max tokens is on how many tokens token is nothing but you can assume like a word on how many words that you want a system to be generated. Okay, yeah, I'll allow you for questions, but yeah, let me complete this, and then I'll allow you for answers as well. Guardrail is LLM. LLM guard is nothing but a guardrail. Let's say there might be some users who are a bit cheeky, and then they would be asking some random questions, or sometimes they will be asking biased questions as well, saying that I want you to be hey chatgpt. They might be using some F words as well. So if there are some toxic or biased comments, my LLM should not answer that kind of things. Then I would be using something called drills, where this drill safeguards our LLM to generate negative responses, which also safeguards us from lawsuits and all. I'll talk about this top PC, stop sequence in detail. All these are parameters are on top of our LLM. Okay, this how our LLM has to generate the response. Let's say if I set my max tokens to be 100, I'll get only the 100 words. Or if I set my temperature to be 0, I will get my answers to be more factual. So all these are negative. It's just like what I can say is that it is. Let's say if you want output in certain format, then you can choose all these parameters, and then you can simply get the answers as well. Okay. And then this is the very good website, guys. I want to introduce in first class itself. So as there are few product managers, and then there are few folks who are into development as well. So this is a website called GenML, where in this website, all the companies or all the guys who are working on Gen AI, they are trying to post how exactly they are implementing this stuff. Okay, so what you can do is that you can see this is released by Amazon company on how they're trying to do multilingual document processing. So this is the architecture of what they are following. What you can do is that as this is Gen AI is trial and error thing, all people are trying to look into the other solutions, right? So you can see how other companies are trying to implement the solutions into their enterprises thing. So this is a very good website that I found on internet, and I want to showcase this to you as well. This might not be used in our first class itself, but in the upcoming classes, I would be taking some use cases from here. And then if you are interested, if you got some idea, you can also pick some topics from here on how other companies, how e-commerce companies, or how other different clients are working on integrating the AI into different streamlines. How are they pipelining that? You can also come up with that, and then you can also present it for 5 or 10 minutes. I'm highly open for that as well. But I would be taking few use cases from here, and then I would also walking you through how this is being implemented and what are they getting as well. So about this course, logistics and all, so you can see this is website where I would be, today is just about introduction. So I would be marking as done. So I would be following this sheet. So you can also follow this sheet, and then there is Google Classroom that I have created for this batch, where under this class, I would be creating PPT materials, this class recordings, and then this is the stream, guys, where you can ask your doubts or you can post whatever you have in your mind. You can ask questions like this, and then I'll also posting the announcements here. And then here is the people or students, the bunch of folks who are in this class. To join this class, I would be manually adding you to our class. So what you can do is that you can email whatever the email ID is, please post that email ID in WhatsApp group that I have added you, so that I'll add you into this group where you can access materials of this class, recordings, and all this stuff under this classroom. Okay. Yeah. With respect to the work environment setup or the setup for this course, you need to download Anaconda, or you can download Python. Python is very is a path, and it is an important language for implementing all this stuff. You can download Visual Studio Code or Windsurf or Cursor, or you can download any of these three, where these three are called code editors. These code editors helps us to write code in simple way. This is agentic AI based code editors. So yeah, this would be the stuff that I need for you in the next class itself. So try after this class, try to install Anaconda, Python, or any of the code editor. It can be Visual Studio Code or Cursor or Windsurf. Try to install that, and then if you are facing any difficulties, don't shy away putting your comments in either Google Classroom or the WhatsApp group that we have created. I would be helping you, or a bunch of folks who are into this course will definitely help you to come up with that, to resolve that issue, whatever you are having. So with that being said, that's all I have for today's class.
Thank you for watching. Please like, share and subscribe to KKR Gen AI Innovations channel.